Hey, it's Paul here, Cisco CCNA in 60 days. It's on Amazon version 4. It'll help you get through the CCNA exam in 60 days, funnily enough. Please subscribe to the channel so you can see all our other videos. We've got full courses being added every week, roughly. And hit the bell. So we're on Syslog, SNMP and iOS. All in the syllabus. It's day 34. Today, do all the things you've been doing every other day. You must keep doing these if you want to pass. The lessons are going to be theory on the Syslog, SNMP, Cisco IOS. I don't think we've got labs, unfortunately. There is labs. You've got the IP subnetting book on Amazon, the Guru, Zero to Guru. I've got SNMP labs on 101 Labs, Cisco CCNA. I don't think I've got it on the 60 days course for whatever reason. So there you go. That's all for today. I will see you tomorrow. Simple Network Management Protocol for the CCNA ICND2 exam. So SNMP, very commonly used on networks all over the world, even from small networks, but especially on medium to enterprise networks. And a lot of the time it'll be a dedicated role for an engineer or a team monitoring the network. So it's a proactive way to monitor and manage your network. One advantage is you'll find most SNMP tools, you do get free ones actually that are pretty robust, but it gives you a graphical way of monitoring your network. So however you configure it, it can actually graphically give you a dashboard where it monitors bandwidth, port utilization. You can also remotely enable or disable ports on your network. It can actually inform the network administrator with emails, or you can even set it up to send texts or other ways of contacting the network manager. So I've said you can remotely control devices. It's application, so layer 7. It uses UD ports 161 and 162. And it consists of 3 main elements: the management system, agents, and managed devices. Here's more information on what each does. The management system is actually executing monitoring applications. So generally it's a piece of management software that will go on a server. Well, I suppose you could run it on a PC, and then it can be accessed via PCs used by several network management engineers. But generally it gives you a pictorial representation of what's going on from the data that is gathered. The SNMP agent is a piece of software code that resides on each managed device, and depending on what the device is, a different agent has to be installed. So for each model of switch, there's a different agent. For PCs, for network cards, each one has to have its own network management agent. Agents use GET requests that transport data to the network management software. Managed element such as a router, switch, a computer or firewall is accessed via the SNMP agent. So this is your actual device that's being managed. And here's a diagram showing you how it all works. Got your SNMP agent running on a router here and a management database, and it sends the information to your network management station. Monitoring devices managed with 3 commands. There's read, write and trap. The read command is used by network management station to monitor devices. The write command is used to control managed devices. Got to be careful if you give write access using SNMP, and this is going probably beyond what you need to know for the CCNA. You do need to know these commands, but in more detail of what you should configure is probably outside the scope of the CCNA. Read access is one thing, write access is a security issue. The trap is used by devices to report events. So if you configure if you want to be informed when bandwidth exceeds a certain amount on an interface, If it exceeds that amount, then the message sent is known as a trap message, and that's sent to your network management station. And here you can see a trap or inform is sent to the network management station. An inform is different to a trap. It actually contains more information and it's more reliable. However, it does use more network resources. The network management station sends information using UD port 161. You do need to know about SNMP versions. I've outlined the main differences for version 1, 2 and 3 here, so you may want to just pause the video for a moment and just look through. The main difference is with version 3 now you get message integrity, authentication and encryption, which is a common exam question. Configuring SNMP is outside the scope of the CCNA, but I've put some configuration commands here for your information. The first one sets a community string, which is a community string's a name which you allocate the permissions to. The first string here is a read only, RO. The next one is a string with read-write access, and then the final line gives you a SNMP server address. It's telling it to send traps. The community string is configured there, and it's a Syslog message. And here's a sample graphical output of SNMP management station. What it's doing is giving you a dashboard type representation of what's going on in the network, and you can see, I think this is monitoring memory and CPU utilization. And whatever you've configured it to do, if it goes over the parameters, the dial will go from the green into the red. Syslog. Syslog is short for system logging. You can log messages locally or to a logging server, also known as a Syslog server. There's some free software on the web actually you can download if you have a network or you want to practice via SolarWinds or Kiwi Syslog Daemon. Now Syslog uses UDP and port 514. There's 8 levels of Syslogs, level 0 to 7. It's probably worth you knowing these levels and also the order that they go in. So not just what they're called, but which one is level 0, 1, 2, 3, 4, up to 7 in the correct order and what they do. Sending Syslog's log messages, you need to enable logging, which is actually enabled by default. I've showed you the command in case anyone ever turns it off. Specify the logging severity. You add the Syslog server, you can have one or more IPs, and if you wish you can specify the source IP that the logging messages are coming from. You can always issue the show logging command on your router, which shows you the current logging level, and I've indicated it in red at the bottom, the level that's configured. Logging level here is informational, so if we go back, that's level 6. Typical logging message here, there's a time, date. In fact, if I do this, so the date, time and date. There's a facility generating message telling you what the message is. You've got a number which gives you the logging level in brackets there. There's a message mnemonic which gives you more information about what the message is, and then also the message description. In this case it's a neighbor 192.168.1.2 and the interface is down. If you want to increase the size of the logging buffer, you type logging buffered and then a number, and you can see the options there from 4096 bytes upwards to a large number. I'm not going to read it out. Logging during telnet. This is a classic way people get caught out in the real world, and I suppose they could ask you in the exam. But if you're telnetted to a router, remember the logging messages by default go to the console session. So if you won't be consoled into a remote router, you're actually telnetted in. So what you need to do is type the command terminal monitor, and what that does is pushes the console output to the terminal session. I've issued the service timestamps here. What this does, it gives you the ability to drill into a lot greater detail time-wise. It stamps all your debug messages up to and including milliseconds. And this is important if the problem that you're monitoring is happening at a very fast rate. If you're just monitoring by the second, then to be honest, you may not have enough granularity. So a lot of the time, Cisco TAC may ask you to log the msec command. So you can see service timestamps, debug, date time, and then msec is the final part of the command. The other thing which it isn't included in the syllabus, but I thought I'd add it here, is you may be asked sometimes to clear counters before you send outputs to Cisco TAC, or you may want to do it yourself. If a router or switch has been in use for days, weeks, months or years and the counters have never been cleared, you won't actually be able to accurately see interface resets or buffer problems. So what you may want to do is issue the clear counters command as it is here. And what that does is clears all of the counters. So you can see back here, for example, we've got 3320 packet input, but once you've issued the clear counters, there's 0 packets input. So it just resets itself. The main areas you'll be looking at are obviously CRC errors and frame errors and runts and stuff like that. But this will clear the slate and allow you to monitor those outputs. Router architecture. So inside the router we've got several modules. Now obviously this all depends on which module you have, and Cisco routers are becoming more advanced. But for the purposes of the CCNA we need to be aware of a few different modules and memory types. We've got flash memory, read-only memory, NVRAM, we've got DRAM, dynamic RAM, and so the central processing unit. So ROM is short for ROM monitor. What that is a tiny image, a tiny set of instructions that allows the router to initialize and checks to see which modules are connected and if the router's operating functionally at a basic level. Non-volatile RAM is where we keep our startup config. There's also something called the config register setting is held there, which I'll come to in a while. Boot flash can be installed on routers depending on the model. This contains a small version of iOS called RxBoot, and it can take the router into a semi-working mode where you can issue certain commands, but it isn't a fully working iOS. You've got the flash memory, which is where the iOS is stored, but it's usually compressed and then it becomes uncompressed and put into DRAM. Your dynamic RAM also contains your running configuration, the buffers and routing tables. Now obviously dynamic RAM, same as any other sort of DRAM that you get in computers, does not have any storage capacity. So your running configuration, for example, when you reboot the router or power it down, you lose that configuration. This is why we save whichever configs we need to save, especially the running config. We save that into NVRAM. Here's just a couple of images from the inside of one of my routers. It's from a very old router, it's a 2500 series, but you can see it's got a motherboard and various processors on there, and this is the DRAM chips. This is flash memory. You'll have flash memory inside routers, but also now you get PCMCIe cards that plug into routers if you want to expand the memory. Inside the router, you've obviously got your Cisco IOS code running, the RxBoot, which I mentioned, the ROM monitor, the startup code, configuration files and device configurations, and your configuration register settings. And you need to be aware of the differences between all these and what memories hold the various files. Boot ROM is EEP ROM, electronically erasable programmable read-only memory. and it's for startup diagnostics, and it does contain a ROM code which basically pulls your iOS system from the memory. Non-volatile RAM, as I mentioned, stores your startup config and config register, so that'll have some sort of power source where it can retain configuration commands. Router operating system can be stored in the flash memory, or as I said, the PCMCIA cards. Your DRAM is for your full operating system when it's expanded, routing config, running tables. I've mentioned the RX boot and the ROM monitor. Your Cisco IOS resides in flash, and that is the operating system that runs your routers and all the features, for example, voice, data, security. Configurations are pulled from your startup configuration when the router boots into your DRAM. So any changes you make to your router configuration will obviously then need to be stored as your startup config. Config registers are a classic topic for CCNA exams, and a lot of people are actually making mistakes when they're not familiar with how routers work. But this sets the instructions for how the router is going to boot, and what it enables you to do if you change it is to initiate disaster recovery. For example, if you've forgotten your passwords for enable mode. The setting, and it's a hexadecimal number that's stored on the register, is 0x2142, tells the router to boot and ignore the startup configuration. So you do that, for example, if you had forgotten the password. If you want it to boot normally, the setting is 0x2102. Now you can change this when you're in config mode, or you have to break into the router as it's booting, and you can do a Google search for example, password recovery, and then the model, for example, 1721. Cisco has a page for doing recoveries for all their different models of routers and switches. There's the configuration command, config-register 0x2102, and that's telling it to boot normally. Now the show version command is very powerful. That will tell you what your config register setting is, as we'll see in a while. So router booting in more detail, the ROM monitor does all the system diagnostics. If there's a problem here, for example, one of the chips has fallen off or there's another issue, then you'll get some sort of error message. You will be in ROM mode if the router doesn't boot any further from ROM monitor. The ROM mode allows you to do disaster recovery and upload another iOS image. RX boot is, you'll see this prompt. I haven't seen it in the modern series of routers. I've seen it in older models of routers, so you may not be able to access this anymore. And then the full Cisco IOS has loaded, allocates buffers, and goes into the router prompt and the greater than. So that's user mode. Important you know how to back up all your files and your iOS. Copy run start will copy your startup your running configuration into the startup configuration. Your router, you can see in square brackets there, it's asking you, do you want it to be called startup-config? You should always leave it as default, because what some people do is they rename it, but when the router boots, it's actually looking for a file called startup-config, and if that isn't there, then it'll presume there's no configuration. You can copy your startup configuration or your running configuration to a TFTP server, usually on the same subnet that your interface is in. You can also copy your flash, contents of your flash to TFTP. It's usually your iOS file. And obviously, for backups, you can do the opposite. You can copy TFT flash. Here's a show version then. You can see how long the router's been up. That's a common exam question actually. Router uptime is 1 minute. And you can see how it was last recovered. So for example, this is returned to ROM by power ROM. So what it means is somebody's power cycled the router. You can see the image in the flash. You can also go down and you can see how much memory. You can see how much memory has been installed. The memory has actually been split by the router, and it's normally, I think it's a 75-25% split for buffers and also for working memory. How many interface, fast Ethernet serial interfaces are configured.
how much NVRAM, and also how much flash memory you have configured. At the bottom you can see the configuration register is 0x2102. iOS licensing now is covered in the CCNA exam, and you need to be familiar with various commands and how the licensing model works. It used to be that you would have, it was a bit of a nightmare, for every single model you'd have many different versions of iOS, and each different version would support different features and functionalities. So it ended up Cisco had to produce, for every new feature that was released, they'd have to add this to 100 or so versions of iOS. So it became a nightmare. So what Cisco have done is put, for every new model, they've created one iOS, and you can unlock various features if you want to pay for them to work on your network for whatever reason. You already get, when you buy a router, an IP-based version, which should run all your basic networking. The data, which has got more advanced features, is locked. Security and voice are also locked. If you want to manage your Cisco iOS, there's a harder way of doing it, which is manually, or you can use Cisco License Manager. Download from the Cisco site. That will manage all of the iOS licenses on your routers and switches and network. And then if you want to pay for extra features, you can either go through the Cisco license portal or a Cisco reseller. Now, each model features a unique device identifier, that's your routers or switches. The unique device identifier consists of a product ID and a serial number. So if you issue a show license, so this should work on Packet Tracer, or if you've got the latest version of iOS running on a new model of Cisco router, for example the 1940 series. Issue the show license, and I've finished it with show license UDI, and you can see your serial number and the UDI is displayed there, so that's where you get that information from. Product activation key, in order to get these advanced feature sets, is purchasable from Cisco systems, and this will obtain your license files for your iOS. Your product activation key matches the various feature sets that you're going to be able to unlock as and when you need them. Your product activation key and then your UDI, as we've already covered, these are submitted online to Cisco. Here's a product authorization key here that I've got an image from, and it's copyright. So this is the Cisco portal where you can actually get the license. You go through all the different steps of putting your product authorization key or activation key, and then you finally do get your license. Final steps. You copy the file to the router with a USB stick, TFTP or via FTP. Issue the license install command, and then you can reload the router to activate all of the features. So here I've got show license feature, and you can see what has and hasn't been enabled. I've issued a DIR to tell me what files are on my USB flash drive that's plugged into this particular router, and you can see a .lic file, which is my license file. Then I've issued the license install, and then the path to the license and the license file name. And then it's telling me it's installed the license, and then I've cut out a lot of the text because you don't need to see it. You accept the license, and then it will install the license for you. I don't think you'll be asked to do a lab on this in the exam. You just need a working knowledge and appreciation. There's a right to use license. This actually lets you unlock features to test. What Cisco didn't want to do is upset customers by locking things, and they also wanted customers to be able to test various features on their network without having to first buy the license. You don't need a PAK to enable the features, and strangely enough, after 60 days the license expires to use it, but it will still work. In order to do this, the right to use license, you issue the license boot module, and then you'll see what choices you have. On mine, it's license boot module, my model number C1900, and then I've chosen the technology package. I've got security K9 to choose from and security technology also, and you can see in the outputs. So I've issued the technology package security K9, I've accepted the license, and then it's installed the license for me. Then reboot the router and your new iOS will show. Issue the show license all, and you can see I've got an evaluation period on the Security K9 image. Now normally that would start off at 60 days and count down, but I've actually issued this on a packet tracer router, so the output's slightly different.